time taken by an object to slide down 45-degree rough inclined plane, time taken by rough inclined plane is n times as it is down as it takes to slide down a perfectly smooth plane, time to travel down smooth plane, ts, is n times. So time for rough is n times time for smooth. Okay. The coefficient of kinetic friction between the object and the inclined plane is. So very good question. It's a really good question because it's it checks your concepts from not just this chapter but a couple of other chapters. All right, let's discuss case number 1 where it is smooth plane. Now in smooth plane, it is a perfectly smooth plane, which means kinetic friction doesn't exist here, right? So there is an object here, inclined plane 45-degree, coefficient of kinetic friction and static friction is equal to 0. The forces acting on the block are normal reaction acting upwards and weight acting downwards. Now this weight can be resolved into two components. One, the vertical component, which is mgy, and the other, the horizontal component, which is mgx. So weight can be resolved into two components, mgy and mgx. Now we know that when we resolve the forces, what do we get? When we resolve the forces, we can resolve this mg into two components, one which is mg cos theta, which is the vertical component, and then we have mg sin theta, which is the horizontal component. Now the only other force acting here is normal reaction. To be more precise, this is normal reaction on the block due to the inclined surface. One more time, this is normal reaction on the block due to the inclined surface. I mean, not this surface, it is this inclined surface which is providing the normal reaction on the block. Okay, so we have the free body diagram. Now let us use the conditions, which is sigma fy is equal to 0 and sigma fx is equal to ma. Now why is sigma fy is equal to 0? See, the motion is taking place, okay, or otherwise there is no motion along the y-axis. What does that mean? If there is no motion along the y-axis, it means that object will keep following only this mg sin theta direction. It will go only in this direction. It is not going upwards or it is not going downwards. It is restricted to the, it is restricted to the x-axis, not to the y-axis. So since there is no motion along the y-axis, we can say that displacement along y-axis is equal to 0. What does that imply? It implies that velocity along y direction is equal to 0. Further, acceleration along y direction is equal to 0, and if you multiply m on both sides, what we get is m into ay is equal to 0. And what is m into ay? It is fy is equal to 0. So we can say that sigma fy is equal to 0, which implies that forces acting upwards should be equal to forces acting downwards. Now what are the various forces acting upwards? The only force acting upwards is normal reaction on the block, which is equal to forces acting downwards is mg cos theta. So we have n is equal to mg cos theta, right? Okay, now what is sigma fx is equal to ma implies? Sigma fx is equal to ma implies that all the force acting in the x direction, sum of all the force acting in the x direction is equal to ma. What are the various forces acting in the x direction? There's only one force, which is mg sin theta. Now you may be wondering, what sign should I take? Should I take positive or should I take negative? See, for that, what is the overall direction of motion? It is downwards, right? What is the direction of mg sin theta? It is also downwards, right? So since both of them are in the same direction, we will take mg sin theta to be the positive one. So this is basically plus mg sin theta is equal to ma, and if you cancel on both sides, what we have is acceleration is equal to g sin theta. Now we already have discussed this as a standard result, that the acceleration on a smooth plane is equal to g sin theta. But however, since we are going through questions, it is good to revise these concepts, and things become as a it should become a perfect memory by practice. It's not that you memorize things; it should come by practice, right? Okay, so now let us go through. Okay, I don't want to go to the smoke plane. Let us now visualize the second part. So what is the second part? The second part is that the object is the same and the block is sliding down, but what's different here? That the inclined surface here is not perfectly smooth. There is some amount of kinetic friction. Alright. Now what are the various forces acting on the body? Since there is kinetic friction involved here, we can definitely say that kinetic friction will oppose the motion, right? The object is sliding downwards. Therefore kinetic friction will be opposing it upwards. There will be normal reaction acting on the block. Again, there will be normal reaction acting on the block due to the inclined surface, right? And then weight of the block acting downwards. Now, when we have weight of the block acting downwards, we know that it can be resolved into two components. One, the vertical component, and two, the horizontal component, right? So the horizontal component here would be mg sine theta, and the vertical component here would be mg cos theta. So we have the free body diagram of the block. Now let us apply the same conditions as we took earlier, which is sigma Fy is equal to 0. Why? Because block is sliding along the plane which is only along the x-axis, and there is no motion in the vertical direction, which is the y-axis. And since there is no motion along the y-axis, we can say that Vy is equal to 0, and further implies that Ay is equal to 0, and therefore m into Ay is equal to 0, which implies Fy is equal to 0, right? And since sigma Fy is equal to 0, we can further say that all the forces acting in the up direction, right? All the forces acting upwards should be equal to all the forces acting downwards. What are the various forces acting upwards? The only force that is acting upwards here is the normal reaction. So we have normal reaction N is equal to what is force acting downwards? The only force acting downwards here is mg cos theta. So this is equal to mg cos theta, right? Some of you may have a doubt here. Isn't that mg sin theta is also acting downwards? No. Why? Because mg sin theta is the horizontal component of weight, whereas mg cos theta is the vertical component of the weight. So that's what we say. So maybe we should stick on to using vertical component. So the vertical component n along upwards, vertical component mg cos theta acting in the y direction, maybe positive y or negative y. Okay, right. But as in the previous case, we can say that sigma fx is equal to ma, unlike sigma fy equal to 0. Now when sigma fx is equal to ma here, what are the various forces acting here? Now here we may have to spend, maybe I just make use of one more diagram so that things become clear to you. So say the net direction of motion is along the plane, right? Kinetic friction is acting against it. Mg sin theta is acting along it, right? So we have mg sin theta along it, whereas kinetic friction is against it. So against the net direction of motion, we will take it to be negative. Along the net direction of motion, we take it to be positive, and therefore we'll write it as plus mg sin theta minus kf, plus mg sin theta minus kf, plus mg sin theta minus kf, plus mg sin theta minus, plus mg sin theta minus. And what is kf? Kinetic friction is coefficient of kinetic friction times the normal reaction. And what is the normal reaction? We just found out the normal reaction to be equal to mg cos theta. So instead of normal reaction here, we can write here that this is equal to mg cos theta. And since normal reaction is mg cos theta, all these three terms now have m with them. And what can I further do? I can divide this entire equation by m, and what do I get? G sin theta minus mu k g cos theta is equal to a. Now I've written AR. What does R imply here? It means acceleration along the rough plane, as opposed to the first one, which was acceleration along the smooth plane. Now you might be wondering that we are asked to find out what were we asked to find out? We were asked to find out the kinetic friction, but we only have the acceleration rough and acceleration smooth here. Now how do we derive it? The answer. For that, what we'll do is we will make use of the equations of motion. Now let's have a look here. So I have taken displacement time relationship. I have made use of the displacement time relationship, which is otherwise called ST time relationship, which is S equal to UT plus half AT square. Now I'll replace S with SR, U with UR, and T with TR. I hope the concept remains clear to you. Why? Because SR is displacement along the rough plane. UR is initial velocity when the object was kept in the rough plane. What is TR? Time taken for the travel along the inclined plane when the plane was rough. Simple? Right. So now we have SR is equal to, since it is from rest, UR is equal to 0. So that term is completely eliminated. So we have displacement along the rough plane is equal to, okay, wait, is equal to, this term is, okay, is equal to half into acceleration along rough into TR square, right? Now, what is acceleration along the rough plane? Let's see. Acceleration along the rough plane is from here is equal to, maybe I can just copy down it over here. So acceleration on the rough plane is this value, right? So we have acceleration along the rough plane as SR is equal to half into G sin theta minus mu k into G cos theta into TR square. Now, similarly, we'll have to find out the case 1 where the acceleration is along the smooth plane. Everything remains the same except that we replace R by S. Initial velocity is 0, that is eliminated, and A here is G sin theta. So we get is SS is equal to, displacement of smooth direction is equal to half into G sin theta T square. Now what we'll do is we'll bring these two equations together and then we'll try to understand what does it mean. I'll write it one more time, right, for better clarity here. So mu k is unknown in both cases. Sorry, in the second case, because it is rough, and this case it is smooth. Now in both the cases, the block is the same, the inclined plane is the same, which means this distance d is the same. This inclined distance d is the same. Therefore, we can say that SR, displacement along the rough, should be equal to displacement along the smooth, should be equal to d, or both of them can be equated, right? And we just found out these two equations, displacement time relationship. But it is given that SR is equal to S is equal to S of D being the same plane, right? Which means these two equations can now be equated. And now if I equate these two equations, what do we get? What we get is half into G sin theta minus mu k G cos theta TR square is equal to half into G sin theta TS square. So the first step would be to, we will remove half from both sides. Now what do we have? G sin theta minus mu k G cos theta TR square is equal to G sin theta and TS square, right? Okay. Now every term has G, so I'll divide this complete equation by G. I'll divide this equation by G. So G is eliminated from the set of equations. Now what we have here is sin theta minus mu k cos theta TR square is equal to sin theta into TS square. But it is, okay, now what's the value of theta? Theta is 45, so it is sin 45. Cos theta is cos 45. Sin theta is sin 45. Now, since it is 45, we know that if theta is equal to 45, sine theta is equal to cos theta, right? So instead of cos 45, I can write sine 45 here. And after writing the same equation, I'll divide this complete equation by sine 45. Now sine 45 by sine 45 is 1. Sine 45 by sine 45 is again 1. Sine 45 by sine 45 is 1. So what we have is 1 minus mu k into tr square is equal to t square. But what else do we have from the question? The question also says that tr square is n times t square, something that we discussed the very first part of the question, right? So tr square is n times t square. So we can write that 1 minus mu k into tr square can be based on n into ts the whole square. Now n into ts the whole square means n square ts square. Now we have ts square on both sides. So what can we do? If we divide this, so we can cancel out these two terms, right? Now what we have is 1 minus mu k into n square is equal to 1. Now this gives us 1 minus mu k is equal to 1 by n square. So if you transpose 1 by n square to the LHS, what we get is 1 minus 1 by n square is equal to mu k. And if you check the final answer, what we get is 1 minus 1 by n square.